So in this video we learn how to find out the eigenvalues and eigenvectors of a matrix. So let us find the eigenvalues and eigenvectors of a matrix A. So the first write the characteristic equation. The characteristic equation of the matrix A is given by det of A minus lambda equals to 0. So that is lambda cube minus the trace of the matrix minus 2 plus 1 plus 0 into lambda square plus sum of the minors of the principal diagonal elements, that is given plus minus 2 minus 3 minus 1 0 plus det of minus 2 2 2 1 into lambda minus det of A equals to 0. This is the characteristic equation. Next, so on simplifying we will get lambda cube minus 1 into lambda square plus on all this, so we will get minus 21 into lambda minus determinant is given as 45 equals to 0. So we will get a characteristic equation as lambda cube plus lambda square minus 21 lambda minus 5 equals to 0. So from this find out the lambda values. The lambda values are 5 comma minus 3 minus 3. Okay, these are called as eigen values of the given matrix A. Let us find the eigenvectors of the given matrix A by using these eigenvalues. So we will take it as a case 1 and 2. So case 1, when lambda is equals to 5. So for this we need to solve the homogeneous system, that is solve A minus lambda I into x equals to 0, where this x is a non-zero vector. We will write it as x1, x2, x3 is a non-zero vector. So write this homogeneous system as minus 2 minus lambda 2 minus 3 2 1 minus lambda minus 6 minus 1 minus 2 0 minus lambda into the vector x1 x2 x3. Now put the lambda value. Lambda is equals to 5. So we will get minus 7 2 minus 3 2 minus 4 minus 6 minus 1 minus 2 minus 5 into x1 x2 x3 equals to 0 0 0. Now use the cross method. The cross method is your determinant method. So write down the x1 by, so neglecting the first column and first row, we will get minus 4 minus 6 minus 2 minus 5, and for second coordinate write down minus, and right here neglect the second column and first row, 2 minus 6 minus 1 minus 5, and x3 by neglecting the third column first row, 2 minus 4. Expand the determinant x1 by 20 minus 12 minus x2 by minus 10 minus 6 x3 by minus 4 minus 4. Now x1 by 8 minus x2 by minus 16 and x3 by minus 8. So take out the common thing. So we'll get a x, the non-zero vector x is, take out 8 common. So 1, 2, minus 1 is the eigenvector for the corresponding lambda value 5. So case 2, when lambda is minus 3, here the root is repeated twice. So for that we need to solve the system, homogeneous system, a minus lambda I into x equals to 0. Here x is a non-zero vector. Is a non-zero vector. So write the homogeneous system as minus 2 minus lambda, 2 minus 3, 2 1 minus lambda, minus 6, minus 1 minus 2, 0 minus lambda into the vector x1, x2, x3 equals to 0, 0, 0. Now substitute lambda value, put lambda is equals to minus 3. So we'll get 1, 2, minus 3, 2, 4, minus 6, minus 1, minus 2, 3 into x1, x2, x3 equals to 0, 0, 0. So since 3 rows are identical, so by the cross section method we can find here x1 by 0, x2 by 0 and x3 by 0. So then whenever we'll get a root is repeated, so eigenvalue is repeated, we'll get the solution set as a 0 set. So we cannot apply this cross section method. So we need to go through the echelon form here. So now reduce the given matrix by using the echelon form. So reduce into echelon form. So use only row operations. So R2 implies R2 minus 2R1 and R3 implies R3 plus R1. We get 1, 2, minus 3, 0, 0, 0, 0, 0, 0 into x1, x2, x3 equals to 0, 0, 0. So since it is an echelon form, now by using the back substitution method we will find out the solutions. So that is x1 plus 2x2 minus 3x3 equals to 0. Let us consider the arbitrary constants as x3 is equals to some k1 and x2 is equals to k2. So find out here x1. x1 is equals to, substituting this x2 and x3 values here. So 3k1 minus 2k2. Write down the solution set. X equals to x1, x2, x3, which is equals to 3k1 minus 2k2, x2 is k2 and x3 is k1. So find out the k1 coefficients are 3, 0, 1 plus the k2 coefficients are -2, 1, 0. So therefore we'll consider 3, 0, 1 comma -2, 1, 0 are the eigenvectors for lambda is equals to -3. Thank you.